We're back with live sound reinforcement, and this segment's all about setting up and getting the PA connected. Dave, before you finish setting up, could you give us a brief overview of the types of gear we have here?
Sure. What we have here is a basic three-way or tri-amp system. Down here I have a subwoofer with two 15-inch drivers, and up here I have a mid and high box with two 12-inch drivers and two 2-inch compression horns.
Okay, so two 15s, two 12s, and two 2-inch compression drivers.
Correct.
Great.
Back here I have the amp racks. I have a stereo amp for the lows, one for the mids, and one for the highs, as well as stereo amps for the monitors.
How many watts for the main speakers?
I have 1,000 watts for the lows, 600 watts for the mids, and 350 watts for the highs.
Well, why is the amp for the highs so much smaller than the amp for the lows?
Well, it takes a lot less energy to push a compression driver than it does to drive an 18 or 15-inch cone driver.
What are some of the things we've got over here?
Over here we have a 24-channel multi-pin cable, which is commonly known as a snake. And what it does is it sends all my mic signal from the stage to my front of house mixer, and then all the returns back to my amps and to the speakers.
And here?
Here we have a monitor, and that's so that the musicians can hear themselves on stage. It's got a 15-inch driver for the lows and a 1-inch compression driver for the highs. I also have some mic stands, some mics, some mic cable, a 24-channel front of house mixer, a front of house drive rack that has my EQs, compressors, and crossovers, an effects rack that has my delays and reverbs.
Excellent, Dave, thanks. Okay, one more time for our viewers. Our tri-amp system includes two subwoofers, each with two 15-inch drivers, two mid-high boxes on each side for a total of two 12-inch drivers and two 2-inch compression drivers per side, a power rack containing stereo amps for the lows, mids, and highs, a monitor power rack containing a stereo amp for the monitors, a 24-channel front-of-house mixer, the front-of-house drive rack containing house EQs, compressors, and crossovers, the effect rack containing the reverbs, delays, and signal dynamics, a 24-channel snake to run inputs and outputs from the stage to the mixer and back to the amps, a variety of mics and mic stands, and the monitor wedges. Dave, let's talk a little more about the speakers in the system. Earlier you said this was a tri-amp system. What do you mean by that exactly?
Well, what I was talking about is we have three separate speaker components. We have lows, mids, and highs. Now they're all processed, crossed over, and amplified separately, creating a three-way or tri-amp system.
So why do we want a tri-amp system?
Well, you don't always. It all depends upon the type of music that your band plays, the venue size, the audience size. If you're a top 40 band or a rock and roll band, then you're definitely going to want the output and the coverage that a tri-amp system provides. But if you're a acoustical act and you're playing in a coffee house, then you don't really need it. But you're still going to use some of the same components: power, speakers, mixer, those sorts of things.
So what size of an audience would this PA provide good coverage for?
Well, PAs are spec'd in watts per head, which you get by taking the total wattage of your power amps and dividing that figure by 4. In our situation, we have about 2,000 watts. So if you divide that by 4, you get 500. So that's 500 people that this PA would adequately cover.
Dave, a moment ago you talked about the output and coverage that a tri-amp system provides. What did you mean by that?
What I was talking about was the frequency response and dispersion coverage that a system like this provides. It's important to have a fundamental understanding of these concepts. That way you can go on out and spec the appropriate PA for your band.
Which is exactly what we're going to talk about next. Speakers are a fundamental part of live sound reinforcement, and it's important to understand what they do and how they do it. And that's what we'll learn next. So let's go to sound school. It's important to understand that a PA system or a sound reinforcement system is an electrical system, and it does primarily three things. First, it converts acoustical energy or sound waves, such as the sound waves produced by a singer or the sound waves produced when a drummer hits the head of a snare drum, into electrical signals, which can then be used within the system. The second function is to mix and process all these electrical signals. This is done with our mixer and signal processing gear, such as equalizers, compressors, and effects. The final function is the amplification and conversion of the mixed electrical signals back into sound waves or acoustical energy, so our audience can hear them. Now let's go back to step 1. We said our sound system converts acoustical energy or sound waves into electrical signals. But how do we do that? With something called a transducer. A transducer is a device that converts one form of energy into another. When we convert or transduce sound waves into electrical signals, we use a microphone. That's right. A microphone is simply a type of transducer whose specific job is to convert sound waves into electrical signals that can be used by the PA system. Using the mixer, we accomplish step 2, blending the electrical signals and processing or altering them with devices connected to the mixer, such as equalizers, compressors, reverbs, and delays. For step 3, we now use another type of transducer to convert the electrical signals coming from the mixer back into sound waves. For this, we use a speaker. Just like a microphone, a speaker is also a type of transducer. However, a speaker does the opposite type of conversion. It converts electrical signals received from the power amps back into acoustical energy or sound waves. That's why speakers are so important in live sound reinforcement. They convert electrical signals back into a form of energy our ears can interpret. Now, let's look at another very important concept, audio frequency. Frequency is the rate at which any kind of motion repeats itself. For audio waves, this frequency of motion is measured in cycles per second, or hertz. A speaker moves its cone outward and then inward in response to electrical signals. When it moves out, the motion creates a wave of compression in the molecules of air directly in front of the speaker. When the speaker moves inward, a partial vacuum is created and the air molecules rush back to fill up the expansion. In this way, an outward compression and expansion of air is created in the air molecules that our ears pick up and interpret as a particular type of sound. When a speaker cone moves outward and then inward, it has completed one full motion, or one cycle. If it takes 1 second to complete this one cycle, then its frequency would be 1 cycle per second. If this motion occurred 1,000 times per second, its frequency would be 1,000 cycles per second, or 1,000 hertz. For cycles per second of 1,000 hertz or greater, we use the term kilohertz. If we see the term 2 kilohertz, we understand that to mean 2,000 hertz. Engineers shorten this to simply 2K. Now, what's so important about all this is that frequency directly corresponds to the sensation of pitch in our ears. The higher the frequency of a sound wave, the higher the musical pitch we perceive to hear. The human ear is capable of hearing throughout a frequency range known as the audio frequency range, or audio spectrum. The full range is considered to be from 20 Hz to 20,000 Hz, or 20 kHz. Live sound reinforcement components encompass roughly 40 Hz to 14 kHz. The area within the range that's necessary for speech intelligibility is roughly 200 Hz to 6,000 Hz, or 6 kHz. The most sensitive part of the human hearing range is between 1 and 2 kHz. So what does this have to do with speakers? Each speaker's output in our Triamp system is designed to reproduce a certain portion of this audio frequency range. For example, the low-end drivers cover the lower range of the spectrum from about 250 Hz and below. The mid-range drivers reproduce the range from roughly 250 Hz up to 2.5 kHz. And the high-frequency horns reproduce the range from 2.5 kHz up to roughly 14 or 16 kHz. These ranges vary by the type of driver used in the system and the manufacturer's suggested crossover settings. Crossovers play an important role in all this because they control which range of frequencies are sent to the amps powering the different speakers. We'll discuss crossovers in more detail later on. Finally, there's the topic of dispersion. Dispersion refers to the ability of a speaker horn to spread out its sound in a consistent angle. There's vertical dispersion, which is that angle from floor to ceiling, and horizontal dispersion, or the angle left to right in front of the speakers. As a sound engineer, there are 3 factors to be aware of regarding dispersion. First, the lower the frequency, the wider it spreads out as it leaves the speaker. Conversely, the higher the frequency, the less it tends to spread out. Second, different components have different dispersion characteristics. For example, there are several types of horns, and each has its own dispersion characteristics. Therefore, combining incorrect components, such as a horn with a narrow dispersion characteristic with a boomy subwoofer, will almost certainly cause problems in a live situation. Third, as we mentioned earlier, a crossover confines the signal sent to the outputs to a particular range, thereby allowing the speaker to reproduce frequencies most suitable for itself. So now let's put it all together. The three functions of a sound reinforcement system are to convert acoustical energy into electrical signals, so that 2, they can be processed and mixed, so that 3, they can be amplified and converted back into acoustical energy. Transducers are the devices that convert one form of energy into another at both ends of the system. A microphone converts acoustical energy into electrical signals, and speakers convert the electrical signals back into acoustical energy. The scientific unit for the measurement of frequency, or cycles per second, is hertz. Frequencies over 1,000 hertz are measured in kilohertz. The audio spectrum is divided into frequencies, which the human ear understands as pitch. The higher the frequency, the higher the perceived pitch. The lower the frequency, the lower the perceived pitch. The drivers, or speakers, in a sound reinforcement system reproduce low, mid, and high frequencies and output them in a dispersion pattern. The lower the frequency, the more it tends to spread out. The higher the frequency, the less it tends to spread out. Dispersion is controlled by the design of the cabinets and the horns. A crossover unit involves 2 or more filters, which determine the frequency ranges to be reproduced by each speaker component. Each crossover point involves both a low-pass and high-pass network, which work together to confine the signal to a particular range, which is then sent to each output. Okay, school's out.
Now that you're up to speed on several fundamental audio concepts, let's get back to the setup. Dave, everything's been pushed in and set up. So what do you work on first?
Well, first I'm going to connect all the power to the amp racks, but I'm not going to turn them on yet. Next, I'm going to make sure that all the speaker runs to the main speakers from the amp outputs are made, which I've done here. After that, I'm going to take the returns from the crossover at front of house and plug them into the amp inputs. And it's going to go low, then mid, then high. I'm going to do the same for the monitors. I have mix 1 and mix 2 and the amp outputs to the appropriate monitors. After that, I'm going to make sure that I've placed the snake heads on the stage, as I've done here. I'm then going to place the monitors and make sure that they're all connected.
So you'd recommend having a snake?
Definitely. I mean, you could run tons of mic cable all over the place, but a snake is a lot easier and much more efficient.
A snake is simply a long cable which contains a certain amount of mic and line cables. Depending on the snake, the stage end may or may not have a snake head on it. The snake head is the input box where the mic cables from the stage are connected. On the other end of the snake, the cables associated with the various inputs on the snake head are connected to the appropriate mixer channels. Other lines in the snake connect the main outputs coming from the mixer, such as the crossover outputs and the aux send outputs for the monitors, to the power amps at the stage. The power amps then output the signal to the main speakers and monitors. As we're doing here, it's often convenient to use 2 separate snakes, one for the stage inputs to the mixer and another from the front of house back to the power amps.
Another thing to remember is don't make any cable runs from upstage to downstage across the stage. That way, you're eliminating any trip hazards.
Any tips on monitors?
Yes. One of the first things I like to do is I like to place the monitor off axis of the microphone. That way, I'm reducing any potential feedback problems. The other thing is I like to raise the monitor up, like I've done here. That way I get the monitor closer to the musician's ear.
So now we've laid out the stage area. We go to work at the front of house now?
Correct. The first thing I'm going to do is walk through the signal flow and make any connections that I need to.
Why don't you show us that?
Sure. First, I'll take the left and right outputs of the console and patch them into my house EQs. Left and right, out from the house EQs into my system compressor. Out from the system compressor into my crossover. Out from the crossover, down the return snake, to the appropriate amp inputs.
You label everything.
Definitely. You need to make sure that the crossover outputs go into the right amp channels.
Or you'll blow your speakers.
Correct.
Now how about compressors and noise gates?
Ah, the dynamics. Well, I'm going to use an insert squid for that.
Show us that.
I'm going to go ahead and insert on very specific channels, like a compressor on a vocal channel or some noise gates on some drum channels. For instance, I'm going to go ahead and insert on the kick drum channel here into a noise gate. Signal will go from the kick drum channel into the noise gate, out from the noise gate, back down the insert, and back into the channel.
Dave, let me stop you there for a second. It's very important to understand that the system compressors refer to the stereo compressor limiter used in the signal chain to protect the main speakers. The signal compressors or dynamics that Dave is plugging in are used to process signals like the lead vocal or the drum mics, which are coming from the stage. What's next?
Well, next I'm going to patch the effects rack. This console has 6 aux outputs. I'm going to use 2 of them for separate monitor sends, and the other 4 I'm going to use for different effects. Aux 3 will be a vocal reverb. Aux 4 will be a vocal delay, and aux 5 will be a drum reverb.
Dave, what about the monitors?
Well, I'm using aux 1 and aux 2 for separate monitor sends. They come out from the console here, into my monitor EQs, out from my monitor EQs, back down the return snake to the monitor input channels.
So you've got reverb and delay units, your effects, connected from the aux sends to the units, back to 2 stereo channels.
Correct.
You've got signal compressors and noise gates on specific channels like the lead vocal and the kick drum patched through the inserts.
Correct.
And you've got 2 monitor mixes set up through aux 1 and aux 2.
Correct.
Great. What's next?
Well, I'm going to go ahead and power everything up. Then I'm going to go ahead and check all my connections through the signal flow and all my main speaker connections. Then I'm going to tune the PA.
Excellent. Okay, let's stop here and take a look at what we've learned so far in this segment.
Start from the stage area first. Set up the amp rack behind the main speakers. Run power to the rack, but leave it turned off until everything is connected. Connect the stage end of the snake to the amps, making sure you've connected the correct crossover returns to the correct amp inputs. Then, connect the main speakers. Next, set up and connect the monitors to the monitor amp outputs. While you're on the stage, you may want to set up the mic stands and mics. After the stage area is connected, connect the snake to the front of house mixer. Then, connect the signal chain. Out of the console into the house EQs, out of the house EQs into the compressors, out of the compressors into the crossovers, out of the crossover down the return cables in the snake to the amps. Next, using a separate harness, connect the signal dynamics, the compressors and noise gates, to certain channels such as the lead vocal, the bass, the kick, the snare, and the toms. Depending upon how many aux sends your console has, you can set up several effects such as reverb and delay. Connect an aux send output from the console into the effect unit input, and then return the output from the unit to a stereo channel on the mixer. If your mixer doesn't have a stereo channel, you can use 2 mono channels. If you connect aux send output number 3 to a reverb unit, raise the aux send master number 3 and then aux send number 3 on any channel to add the effect to that channel. Bringing the effect back into the console on a stereo channel or 2 mono channels allows you to pan the effect in stereo as well as add EQ. Use another aux send output to set up a monitor mix. Patch the aux send output from the mixer into the input of the monitor EQ. Then, out of the EQ down a return cable in the snake to the monitor amp input. Connect the stage monitors to the monitor amp outputs. Raise the aux send master, in this case aux send master number 1, and then dial in the amount of monitor signal you want by raising aux send number 1 on any mixer channel. Finally, remember that power goes on last and off first, so be sure to keep it off until you've connected everything in the system.
Okay, so now the system is connected and we're ready for the next step, which is a process called tuning the PA. This involves the use of the system crossover and house EQs, as well as an understanding of how to deal with the acoustical problems that exist in any given room. As you'll see, tuning the PA is a critical part of setting up. So before we get into it, let's pause here for a quick break. We'll be right back with more of live sound reinforcement.